Your standard states that you must understand that polynomials form a system analogous to the integers, namely they are closed under the operations of addition, subtraction, and multiplication. Add, subtract, and multiply polynomials. You see the word multiply polynomials in bold because that's what you're going to be focusing on today. On the A-Net assessment that you took before break, you were required to create an equivalent expression to the quantity 4x minus 7y squared. This right here is a power of 2, and a power of 2 means that you are multiplying something by itself. Because that 2 is outside the parentheses, the quantity inside 4x minus 7y needs to be multiplied by itself. You can do this using the area model or the distributive property, which I'm going to model both for you here. If you're going to use the area model, I'm just going to go ahead and recopy down the problem. 4x minus 7y quantity squared. Remember again that the power of 2 outside the parentheses means you're going to multiply what's in the parentheses by itself. So you're going to set it up listing 4x minus 7y on the left, as well as 4x minus 7y across the top. Draw your diagram, 2 terms across the top, split it into 2 columns, 2 terms across the side, split that into 2 rows. And then you're just multiplying like a multiplication table. To get the first box, you do 4 times 4, which is 16, x times x, which gives you x to the power of 2. Next box, multiply the coefficients. 4 times negative 7, negative 28. X times y, 2 different variables, just leaves you with xy. Bottom box, same thing, negative 7 times 4, which again gives you negative 28. A y and an x, different variables, so you just write them separately. And then the last box, negative 7 times negative 7 makes positive 49. Y times y gives you y to the power of 2. Then you go ahead and take what's inside the box and add it up. So you're left with 16x squared minus 28xy minus 28xy again, and then plus 49y squared. So that's how you would complete the area model. You also have the option to use distributive property, which if we were to set that up, remember again that the exponent of 2 outside the parentheses means we're multiplying what's inside by itself. So it may be rewritten as 4x minus 7y times 4x minus 7y. To distribute, you're going to take each term in one quantity times each term in the second quantity. So 4x times 4x, 4 times 4 is 16, x times x is x to the second. Then you take the first term times the second. 4 times negative 7 is negative 28. X times y is just xy. Now that you've multiplied this term by every term in the second one, you're going to move to the second term. Negative 7y times 4x. Negative 7 times 4 is negative 28. Y times x is just xy. And then negative 7y times negative 7y. Negative 7 times negative 7 is a positive 49. Y times y makes y squared. And notice that you have the same expression here as you got when you did the area model. Now, once you have multiplied the quantity by itself, which we did here and as well as here, we need to simplify the expression by combining like terms. So you have 16x squared. You have another term that has an exponent of 2, but they're 2 separate variables, so those are going to stay separate. So we just bring down 16 x to the second. The 2 terms in the middle both have xy, xy, so we combine those by saying negative 28 minus 28, which gives us negative 56. And the variable and the exponent stays the same, x, y. And then you bring down your last term, plus 49y squared. And we have now created an expression equivalent to our original.